All right, hi there. This is our video lesson for our learning target 1.2a, and I've split 1.2 into two sections. One will be we're going to look at literal functions, that is when we have no numbers that we have to insert for this first part. Again, our videos are for if you're absent, if you want to review a little bit more. So for the warm-ups, we skip the warm-ups in our video. We do them in class. So let's go down to our first part here. We're going to be performing operations for literal functions. And so we are going to learn to add, subtract, multiply, or divide by operating on their rules. So here's a little chart here for their rules. We have addition, and what we're used to seeing here is that this is going to say whatever f is, it usually says over here where we have the f of x plus the g of x, they condense it and they write it this way. So we're going to start seeing it this way. F plus g of x. Oops, sorry about that. Let me go back to my camera. And we also have it the same way with the other operations. So we would normally, sorry about that, I'm not sure what's going on here. We would normally want to see it as this f of x because we know that's one function minus and then another function. And the important part here that I want you to note for subtraction, even when we were back doing equations, is we will always have to put this second one in parentheses. So I want you to write the little parentheses. We always put that second one in there, and we're going to be using the distributive property with whatever sign or number is on the outside. So I, just by a rule of thumb, like to put everything in parentheses because we're taking one whole entire function and we're doing an operation to the second entire function. The next one, multiplication, again, you would want to see it as f of x, so that's one of the functions, times g of x, but they will write it as fg, which we know when things are smushed together, that means multiply, and then of x. So that means times, that's what it looks like. And then the last one, when we have division, you're going to see it looking like this, f divided by g, and then the x out front. We would want to see it as f of x divided by g of x just because it would make more sense. But this is the function notation that's how we're going to see it. So we're just going to use this chart to kind of memorize the function notation for this. So literal means we're not going to have numbers to substitute in. We're just going to be manipulating two functions, possibly three when we get to the combining. But looking at example number 1. What this is saying is, remember, addition means you take your f of x, that's going to be, I like to color code things, so I'm going to use one color for the first one. So f of x, that's my first one here. And we are going to take that, and it wants us to add it to g of x. So we're going to use the g of x right here. That's our second function. So we will just end up taking the first one, 2x squared plus 4x minus 6. And then again, it wants us to add it. And with addition, you don't have to put parentheses, but with all of these operations, what it really wants us to do is take this whole entire function. So I'm putting parentheses just because you will need them with other operations. And then we're going to add, and the second one is our g of x. So our g of x is right here. It's that, I'm going to put a parenthesis, 2x minus 2. Okay? And as we know with subtraction, we can just start combining like terms right away. There's nothing else we have to do. So addition problem. When it's addition, we can start combining terms right away and just condense things down. We do not have to do any extra work. So addition is the easiest one. We like that the best. So let's look at the combining of like terms. So I'm just going to use a pencil to complete the work. But we're going to look at, is there anything else that's an x squared? No. So I'm going to drop that down to x squared. Do we have anything, and then I cross it out after I use it, anything that goes with my positive 4x? Remember, the sign that's in front of it stays with it. Well, I notice I actually have a positive 2x, so that whole entire thing. So 4 and 2, that would give me a positive 6x. And then the last part, numbers, so I have a negative 6 and a negative 2, combining like terms. If we combine those together, I get a negative 8. So this would be our final answer for f plus g of x. All we could do there was simplify. Okay, let's move to the subtraction one. This is the one where it matters for the parentheses, and that we also have to think back to the distributive property or changing signs. So again, this first one, it wants me to take f of x minus the g of x. So I'm going to go back and I'm going to look. My f again is in, I use this burgundy color. So I'm going to take this first one and I'm going to take 2x squared plus 4x and then minus 6. That's my first one. I put it in parentheses just because that's a habit I've gotten into. And then the next part is we are going to subtract that. So I'm going to use my pencil because it's neither color. And I'm going to write my next function, which is that g. So it becomes our 2x minus 2. And remember, we're subtracting that whole entire thing. So we have to put the parentheses, at least on the second one. It really matters. So going back, remembering when we have a negative outside of parentheses, when there's more than one term in here, I sometimes draw the invisible 1 because it's like the distributive property, -1, -1. What that means is we actually just have to distribute the negative and flip the sign of each thing. So if I went and I flip the sign, this is going to become a negative 2x. And if I went here and I flipped the sign, that's a negative 2, it's going to be a plus 2. And then I did not use anything in the front yet, so I'm going to drop that down. 2x plus 2x squared plus 4x minus 6. And then there's already a negative sign on our 2, so we're going to use that as a minus sign. It doesn't matter because when we go to combine like terms, it's all the same thing. So again, now once we get to this point, we can just start combining like terms. I notice right away I have a 2x squared. There are no other x squareds. So I'm writing 2x squared. Used that, so I'm going to cross it out. Now I have a positive 4x, and I'm going to combine that with anything else that has just an x. Again, we have to take the sign in front of the number, so this is a negative 2x. Combine means we add them together. So 4x minus 2x, or plus a negative 2x, that would actually give me plus 2x. I used those. And my last two, I have a negative 6 I need to combine with a positive 2. The signs go with each other. So this becomes minus 4. So that's as simplified as it gets. Nothing else can go with each other. So at this point, I want you to pause the video and I want you to try the checkpoint. For example, 1 and 2. Just remember, when you look at the bottom here, f is different. F of x, our f, is now this thing. So that's what's going to go first, because that's what it wants, f plus g. And then our g is something different. This is going to be, our g is over here, it's that longer one. The g is here, so it's that longer one. So remember, I like to color code. You don't have to. But I want you to go ahead, pause the video, and then you're going to unpause it and check your answers against mine. So you would be doing 5x minus 6. That's your f. I put that in parentheses. The plus sign. And then we have our g, which is x squared minus 5x plus 6. Again, I put that in parentheses, not needed, but it's a good habit to get into because it matters for other operations. Remember, when it's addition in the middle, we can just drop the parentheses and start combining like terms. So that's where I get out my pencil here. So right away, I'm going to just start here. Is there anything that goes with my 5x? That's a positive 5x. Oh, I notice there's a negative 5x. So what happens is these actually cancel each other out, and I don't have any just x terms. If I go back through, I notice I have a negative 6 and a positive 6. Well, those give me 0. So again, those cancel out. And all I'm left with is an x squared. And that's the final answer for that one. If you did that one correctly, you had a lot of the things ended up canceling out. So looking at the next one, if you did that correctly, so your f again is, I'm putting it in parentheses, 5x minus 6. And then I have to subtract, and I like to put the minus, and then I like to put the 1 here because we know that it's the distributive property. And then I put my parentheses of the next function. X squared minus 5x plus 6. And then remember, all we have to do is make sure if we multiply everything by a -1 or that negative, our sign changes for everything. So we're not doing anything with this 5x minus 6 right now, but we are going to do -1, and that's going to change. So that becomes -1 times x squared. So it's a negative x squared. So I just drop that down. The negative times a negative 5x. So that becomes a positive 5x. They just undo each other. They become opposites. And then a -1 times a positive 6 becomes a -6. It's just a sign flip, also known as the distributive property. So when there's no number here and it's just a negative, it's a sign flip or distributing a -1. So now that I'm here, I'm just at the last part where I start combining like terms. So the first thing I like to start off with, I just go from left to right. So I have a 5x, and that could also go with another positive 5x. Remember, you take the sign in front of it, and I get 10x. And cross those out because I used them. And then I have a -6 plus a -6. Okay, that gets me minus 12. And then my last one is I have a negative x squared. So remember how we write this. We would put that out in the front, negative x squared. And then since that's a 10x, we would put a plus sign in front of there because it's a positive. And then we would write it that way. That's just the correct format. We go from x squareds to x's to numbers. Okay, so hopefully you got that. All right, let's look at the next target. So this is going to be multiplication with our operations. And so this looks a little bit different. This has a number in front of it. However, we are still just translating that to a literal function. We're not plugging in any number for x. We are multiplying a function by something outside of it. So this first one, it says 3 times this whole entire m of x. So if I look up here, m of x, and it's not this one, m of x, I'm going to underline in green. And it wants me to take 3 times this m of x. So I'm going to do 3, and I'm going to times the whole entire m of x, because that's what it's telling me to do. 4x squared plus 3x minus 5. So that's all the multiplication is doing. You have the 3 out front, and you're multiplying it by the whole entire function. Again, this is why we put parentheses. So this is distributive property. I have to distribute, meaning multiply every single term by the number on the outside. And remember, the sign in front of the number matters. So this is 3 times a positive 4x squared. So this becomes 12x squared. This is 3 times a positive 3x, so it becomes plus 9x. And then we have a 3 times a negative 5. That's very important. We get a negative 15. Okay, so that is it. There is our answer simplified. Okay, let's do B. So this one wants me to take a -2 and multiply it by this h of x. So I'm going to go over here. H of x is right here. So I'm going to take negative 2, and again, I'm going to put that in parentheses, this function, 3x to the third minus 1. Oops, sorry, that's an ugly parenthesis. So again, for the multiplication, we are just going to distribute right now. So that negative 2, it just wanted us to multiply it by the entire function. So negative 2, there's two things inside of here, this term and this term. So negative 2 times 3x to the third, so just the negative 2 and the 3 gives me a negative 6, and the x to the third stays the same. And then the second part, very important, it's a negative 2 times, this is a negative 1. So you have to be careful, so it becomes a positive 2 or plus 2. So then we are finished here. And that is it for the literal part of multiplication. We can only simplify so much. So I want you to pause the video now, and I want you to try the checkpoint for 3 and 4. Okay, so for the first one, you should have had 15x to the third minus 5. You were watching those signs when you multiplied and distributed. And number 4, you should have had negative 12, x squared minus 9x plus 15. Again, watching the signs as you distribute. So this last part for our notes, 1.2a with the literal, I want you to go to the next page, and we're going to look at the part, this part here where it says example 3, sorry, you can't see it up there, and where you have combinations of operations. So that means I might throw some adding, subtracting, multiplying, and dividing all at you in one problem. Again, you're not inserting numbers into here yet. You are just doing the literal equation of it. So we're going to go through everything we have practiced on the front or the first part of the notes, okay? So just looking through, again, I like to color code. So I'm going to call a of x. I'm going to use that with one of my colors. So I know that that's one of the functions. I'm going to be using this part here whenever it calls for it. And then I know I'm going to have this part here, my b of x. I'm going to use this part when it calls for it. It's actually a really long one, but that's okay. And then the last part, I'm going to use my c of x. Okay, and it's a smaller one. It's right here. So whatever it's going to tell me to do, I'm going to be using the operations and what we've practiced. So this first one reads 3 times a of x. So my a of x is pink. So I'm going to put that part first. I'm going to go little by little. 3 times the whole, whatever a of x is. Remember, I'm going to have to put it in parentheses because it's going to be distributed. 5x squared plus x plus 3. I have that 3 times the whole thing. Okay? I like to put my arrows in just so I can count. I have 1 term, 2, 3. We'll come back to doing the rest in a second because I want to read through the rest of the problem. And then it says plus, so I'm going to put a plus sign here, 2 times c of x. So my c, I used purple, c of x is this. So I have to, again, I'm going to take 2 and I'm going to times it by that c of x. 2 times, remember that's my parenthesis, c of x is 8x minus 4. So I have to remember when it's adding, first I'm going to go through and I make sure I'm going to distribute. And then when all that is done, I can combine like terms. So the first part I need to distribute. 3 times 5 is 15x squared. 3 times a positive x. Remember, that's like the imaginary one. So it's a positive 3x. And then 3 times this 3. Again, that's the sign in front of it. It's a positive, so it's 9. I distributed that, so then I'm going to go through. There's a plus sign here. And so this, again, this is a positive 2 then. So when I distribute it, it's 2 times 8, which is 16x. And then 2 times, that's a negative 4. We have to be careful. So that becomes a negative 8. So now everything's distributive. I have all adding and subtracting, so I can combine my like terms now. So I have a 15x squared. That's going to go out front. There's no other x squared. And then I'm going to go through and I'm going to look for my x terms. I've got a positive 3x and a positive 16x. So 16, 17, 18, 19. Positive 19x. I'm sorry. And then I'm going to do my here, just my numbers. 9 plus negative 8, or just 9 minus 8. So this becomes a plus 1. And then I am done. So I combined two different, I multiplied and added in that one. Okay, so now I'm going to look at B and look at what it's trying to tell me to do. I can see right away I've got multiplication and subtraction in there. So it wants me to take B of x. Nothing is in front of it, so I'm not multiplying this part. But B of x is this big long one. I use this like blue color or greenish color, so I'm going to use that for my B of x. Negative 4x to the third minus 5x to the second minus 9x plus 1. That's all my B of x. And then I'm going to do minus. And remember, the minus just goes in between it. And it wants to do the minus 4. And then we're going to times all that, because when they're smushed together like that, we are timesing by a of x. A of x I used in my pink. So I have to put a parenthesis. Remember, when there's timesing, there's a parenthesis. So I have 5x squared plus x plus 3. And I like to write that little 1 in front of it. It will help me when I go to distribute. So the next part I'm going to have to tackle is the distributive property on this second portion. Because there's minus sign in here, that it can go two ways. We can say minus 4 or negative 4. It's really like a negative 4 times this whole entire thing. So we're going to use it that way. We're going to distribute this negative 4 to everything inside that second function. We're not doing anything with these parts yet, so I'm going to drop them down. Negative 4x to the third minus 5x squared minus 9x plus 1. But I know I'm going to have some kind of symbol that goes here, either a positive or negative, and then I'm going to simplify the rest of this and drop it down. So my next term is going to go right here. So negative 4 times 5x squared. So a negative 4 times a positive. So that's going to get me a negative 20x squared. So that's where my sign comes in. It's actually going to be a minus sign. And then I have a negative 4 times a positive 1x. So that's negative 4x. And then I have a negative 4 times a positive 3. And that gives me a negative 12. And now my next part is to simplify combining like terms. Everything is now adding or subtracting. So I'm going to go through. The biggest one I have here is a x to the third. So I'm going to see if there's any other to the third powers. There's not. So I'm going to put that one first. I used it, so I crossed it out. Now I'm going to go for the x to the seconds. I have a negative 5, and I have a negative 20x to the second. So these two can be combined. When we add a negative 5 and a negative 20, we get a negative 25. And remember, this stays the same. That's on it. We're not doing anything with that. So I use those. I'm going to cross those out. And now I have x terms, just an x. So I have here a negative 9x, and I have a negative 4x. Again, we add them together, negative 9 and negative 4. That gives me a negative 13x. And then the last part, just my numbers. So I have this, a positive 1 and a negative 12. So 1 minus 12 or 1 plus negative 12, we're going to have a negative 11. And that is simplified. So your job now is to do the checkpoint. I'm going to have you for the checkpoint just make a slight adjustment. Okay. So for this checkpoint, I want you to cross out for number 5, this entire first thing, all so that it just says b of x plus 3 times c of x. You're going to be using the same ones up here. I'm not giving you 3 operations though yet. So make sure you cross that part out. And then the other one, I'm going to have you cross out the back part, the plus b of x. Again, we're only going to do 2 of these operations. So you're going to take a c of x minus, and you actually do have another operation. You have to take the -2 times this whole entire thing. So it's very similar to example B. Okay, so you're going to pause the video and then you're going to try these on your own and then check your work against mine. Okay, so looking at my checkpoint number 5, you would have had -4 x to the third minus 5x squared plus 33x minus 11. If you didn't get the correct answer, just check through the work and maybe see where you went wrong. And then the 6 for our checkpoint, -10x squared minus 6x minus 10. Again, if you didn't get the correct answer, look through my work to see where maybe you could have made a mistake. Okay. All right. So now you are going to do the practice 1.2a that goes with these literal ones, just rearranging, adding, subtracting, multiplying. There will be some division, but the rules are the same. We are just doing the operations and simplifying. We're not plugging any numbers in yet. Okay. So that will be your homework. And if we're in class, we have class time to do it.